who had sustained brain trauma, in all cases, could do nothing about it because machines do many glorious things, but they don't grow new parts, they don't rewire themselves. In medical school, I was taught all of these things and that there were no new cells in the brain. And anyone who had a normal brain, who hoped to improve it or maintain it as they aged, was probably wasting their time. And above all, human nature, which was seen to emerge from the brain, was also seen as necessarily fixed insofar as we saw the brain to be fixed. Now, all this turns out to be spectacularly wrong. I'm not saying that the brain is infinitely malleable. I'm not greeting a bad metaphor with another extreme statement. I'm saying that we've underestimated what our brains can do, and that we have to move more to the sensible middle in understanding and appreciating what change is possible. And the following question, of course, must occur to each of us, which is, okay, so if the brain is plastic, if it's been plastic since the beginning of our species, how is it possible we missed it? And there are really four reasons. The first one is a very simple one I'll dispense with quickly. It's we didn't have the technology to view it. We needed to be able to make microscopic movies of the brain because the brain change takes place microscopically. The second reason is a profoundly important one, and it's the mechanistic bias. The ancient Greeks didn't have a mechanistic view of the brain or nature. They saw all nature as one vast living organism. The microcosm, the macrocosm in some ways reflected each other. And anything insofar as it moved was thought to be alive, and insofar as it was ordered in some way was thought to be intelligent, and insofar as it took up space was thought to be made of matter. So they weren't in principle inclined to view anything as machine-like. They viewed things as much more organismically, and therefore there's a scene, for instance, in Plato's Republic, where Socrates says, I think that you can actually exercise the organ of thought the way people exercise when they do gymnastics. And this was a stream of the Western intellectual life. But it got submerged with the rise of modern science. Modern science has many potential beginning points, but one of them, of course, is Galileo. Galileo looked at the same planets that were thought to be animated by the Romans, so animated that they were given names like Mars and Jupiter and Venus, names of the gods, and he basically was able to determine that they were inanimate and they were moved about by forces. And his achievements were so grand that scientists began to think of the entire universe as a cosmic clock. And then biologists tended to take that model of mechanistic understanding and apply it to the organs inside our bodies. And William Harvey, who discovered that the heart was that the heart circulated the blood through vessels with valves and it was essentially a pump, began mechanistic biology brilliantly. But of course a pump is a machine. Shortly after, René Descartes, the philosopher, described the nervous system very much like a pump, and that there were currents that moved up and down the nerves. They were kind of an animal spirit or fluid, which we later learned were electric currents. And it soon seemed to scientists, whenever they were studying the brain, that the only explanations that were of interest were ones that saw it as machine-like. And even our modern medication models are very much a kind of lock and key model. They're very simple and mechanistic, and they surely simplify what's happening in the brain. Under the influence of Descartes, doctors began working with people who had had strokes, and Paul Broca had a patient who lost his ability to speak. The last words he said before his stroke, the last syllable was tan, tan. And after this man who came to be called Tan Tan died, he did an autopsy on him. And he found that there had been severe damage in this part of his brain, the left frontal lobe. And he got some other cases and soon declared that we speak with our left hemisphere. This was the beginning of what was called localizationism. And again, it merged into the idea that each part had just but one function. The problem was there were exceptions to this from the very beginning. But it was so appealing to think that there was one part and one mental function, and they always worked together. Because the brain is so complicated. It's the most complicated object in the universe, that we really wanted to divide and conquer it to understand it. And localizationism took off and had many great accomplishments. But it went so far, it went too far. And the third reason that we miss the fact that our brains are plastic is because even when people did get better from strokes, and it happens from time to time, it was explained away. And what we would say is that this person's brain wasn't really damaged. It was just in shock. There was too much swelling. There was a metabolic derangement. And when they got better, all that happened is it just showed what they always had. They never lost cells. And I want to tell you one story about it, because it's the story of one of the first neuroplasticians I saw, Dr. Paul Bachirita, and his remarkable, remarkable family. And I don't have time to go into it, but he was the man who developed sensory substitution and showed that one sense can substitute for another, and that he was the person who actually taught people who had been congenitally blind since birth to begin seeing by getting input through their skin and tongues. Paul Bachirita was a polymath and a polyglot, the real thing. His father, Pedro, was a Catalan poet. And when Pedro was in his late 60s, he had a stroke. And he got the usual 6 weeks of rehabilitation. And then the doctors called, and they basically said to George, the other son of Pedro, come pick your father up. You have to find some place to house him for the rest of his life. And George was just a medical school at the time in Mexico. And he had no preconceived notions of the brain being fixed, because he hadn't taken that lesson yet. And he knew his father's indomitable will. So he took him down to the villa where they lived with a bunch of medical students, and he winged it. And he said, Papa, you learn to walk by learning to crawl like a baby, so we're going to get you to do that. And Pedro, he cooperated and got down on all fours. And when he was able to crawl, he took him outside of the villa where they were, and he got him to put one hand up on the wall, incrementally giving him some exercise, and got him to walk around. And then the neighbors thought it was very unseemly as to what they were making the old man do. And eventually he got up on all fours, and then he taught himself to type with the same sort of incremental principle, raising a hand, letting it fall, then letting just the wrist fall, then one finger at a time until he could type again, and eventually taught himself to speak. And 7 years later, he was remarried. He was a widower. He remarried. He went back to teaching, and he was climbing a mountain in Bogota, Colombia, when he had a heart attack, a fatal heart attack, and he passed away. And this is where the story gets interesting. The body was sent back to San Francisco, where Paul was working as a doctor, and he ordered an autopsy on his father. And a couple of days later, he got a call from the pathologist, and he went down to the lab, and there on the table before him were spread slices of his father's brain. And he looked at them, and he was numbed, but he also saw something there that was very, very important. When he looked at the tracks and the cells that governed movement in the brain, he saw that 97% of those cells and tracks had been wiped out. So what that meant was, this was not a case of a man who didn't have real cell death and just got the pump primed with a little bit of exercise. What it meant was that the work that Pedro had done with George had completely and utterly reorganized his brain. And Paul Bachirita went on to be really one of the first champions of his generation of late brain plasticity, and develop these sensory substitution devices, which are so very remarkable. Now, there are many, many different kinds of interventions that are available for people who have had brain traumas. But in general, what happens is, when there's a brain trauma, just as when you hurt